Welcome everybody to Unveiling the Magic, the secrets behind 10 amazing web apps session. We're really glad you joined us today. I'm Julie Powell, and I'm a Principal Product Manager for Web Development Technologies at Esri, and I'm joined here with Raluca.
Hi everyone, I'm Raluca. I love the web, I love 3D and cartography. My background is actually in cartography. So anything related to visualization and web UI, UX, I'm happy to chat with you about it, and I'm happy to show you what I've been working on.
Hey everyone, I'm Sajid Thomas. I'm a solution engineer at Esri, and I pretty much build proof of concepts. I've been doing this for a really, really long time, and for the last 4 years, I've been focused on building digital twins. And I will be showing a lot of twins today. So what is this session all about? So Unveiling the Magic, basically at Esri, we build a lot of applications. And we kind of assume that you guys are doing the same thing, you know what tricks we are using. Every time we meet somebody or show somebody an app, we are told that, how did you do that? Or, what are you using? So we thought we'd put this session together today. So what we're going to do is we're going to show you 10 applications. Some of these are old applications, some are new, some we've built just for this session. And we're going to try and dissect the apps, not go line by line in code, but we're going to point out some key tricks or features from the SDK that we've been using. So basically, Raluca and I are going to show off today, and Julie's here to remind you that if an idiot like me can build these apps, anybody can, because we are basically just using the JavaScript SDK.
And Sajid, before you begin, I should say I'm moderating the session. It's a hybrid session, so if you are connected, you can put questions in the chat. I'll try to answer them in the chat, and then we'll also have a Q&A at the end.
So I think it's been like 9 or 10 years since I've presented at Dev Summit, and I think all of you look too young to have been here 9 years ago. So I think it's only appropriate that I warn you, this session is rated R. Depending on how my demos are going, I might switch to French. So if you're easily offended by French with an Indian accent, there are 15 other sessions happening right now. I mean, the choice is completely up to you. So let's get into some of the apps. The first set of apps that I wanted to show you are just digital twins in public transportation. So this is real-time monitoring of transit buses and transit trains. And I'm just going to switch to the app real quick. So this is Boston. We're actually monitoring the Boston Metro buses in real time. This is actually using an integrated mesh layer. So how many of you are using this in your apps? Anybody? There's a couple of hands over there. It's kind of hard to see you. So an integrated mesh layer is just like any of the other layers that you use in your applications, like a feature layer or a building scene layer. And essentially what it does is it's taking aerial imagery that you can analyze, you can process, and you can create this 3D mesh, and it's really beautiful. But that's basically 2 lines of code that gives you a whole city, the whole city of Boston in 3D. And on the tray on the bottom, you can actually see the real-time buses, and we are analyzing the buses for risk. So it's looking at recent crimes, and if there are any crime incidents within half a mile of the bus location, it tags it with a risk level. It's either high, medium, or low, depending on the type of crime incident. So I can just pick one of the buses over here, and you'll notice this is the 1292 bus, and it stopped at a stop, and now it's at a high risk level because there was an incident within 0.04 miles. Or I can pick another bus over here, which is on the green D line, and it's actually going in and analyzing that, and it's seeing which incidents have happened close to that. So this is actually happening in real time. As the bus moves, it goes and looks at recent crime incidents that have occurred near the bus, and it's going to update the risk level of the bus. Now, I know some of you are thinking we don't really have an integrated mesh layer. or we don't have aerial images to create this kind of twin, but you can do it with the building scene layer as well. So this is the same thing. This is monitoring Tokyo Metro trains in real time, but I can go in and select a train line, and then I can look at a station. So I can go in and say, show me what's happening at a particular station, and it'll show me when the next train arrives at each station on each platform. So every direction, all platforms, it's just showing me when the next train arrives. Or I could go in and just select a train on the line, and it'll actually follow that train in real time. Now, this is actually simulated data because it's late at night in Tokyo and there's no trains running right now, but it actually runs in real time. So you can monitor the trains. I could go in, pick a different line. So I'll just pick, and then follow a train over there. So how are we building these applications? Because you'll notice it's like really smooth animation. If you try and do this with graphics, if you have tried to do this with graphics, it doesn't perform as well, right? So I'm going to switch back to the slides and show you what we're doing. So underneath it all, we're actually using ArcGIS Velocity to do the analysis in real time. So that's not happening in the client application. So we have all of the base data, like the integrated mesh layer in Boston or the buildings in Tokyo that are coming from ArcGIS Online. But we are also using Velocity to ingest real-time vehicle data and crime data or delay data. In Tokyo's case, we don't have crime information, but we're just looking at how slow a train is running, and then we compute where the train should be along the track. But in terms of the tricks, there's one simple trick, which if you're not doing this, you're going to kick yourself because it's so simple. Both our map view and scene view have a two-screen method. So you can take any location on the map and convert it to a screen location, so in pixels. So essentially, when you see those divs transitioning in 3D, it's basically a div on top of the map, and I'm converting the map location to a screen location, and I position the div over there. Now, because it's a div, you can apply all kinds of CSS tricks to it. So you can transform it in 3D, and it's a simple div that you're just overlaying on top of your map that you animate, and you can rotate it depending on the angle that you want with the map, right? So it's really simple. It takes about 5 lines of code to do this. So this was the simple trick, and I'll use this pretty much in every application I build. The second trick is a lot more complicated. So how many of you have used external renderers in the past? Anybody? One gentleman over there. Okay. So in the JavaScript SDK, in the scene view, there's actually a rendering engine that has a rendering pipeline, and it goes through a sequence of events when it renders the map. So it'll first do the terrain, then it'll do the layers on top of the terrain, then it'll do the 3D buildings that are opaque, then it does the transparent buildings. And so with an external renderer, or with RenderNodes is the new version of it, what you can do is you can define your own rendering node. So you actually create a subclass of the render node, and then you can define the logic in WebGL on what you want to draw, and you can insert it at a certain level. So you can say, add my render node to the render pipeline at this certain point, maybe after all the opaque layers are drawn, or maybe after all the transparent layers are drawn, or maybe after everything is drawn, you want to go ahead and add it. So you're actually writing WebGL code. So this is GLSL. So it's kind of, if you're not a GLSL developer, it's a high curve to get into. But once you figure out the first one, it's like super easy to do all the others, right? But you can define this render node, and you can add it to the render pipeline. And so you can actually animate things. So the pulse is typically you're just drawing a circle, and then with each redraw, you're just scaling it slightly bigger. And then once it reaches 100%, you go back to 0 and start all over again, right? Now, I use these two tricks in almost all of my apps, but Raluca is the expert on render nodes. So I'm going to hand it over to her to show some of the applications.
We'll show render nodes a bit later on, and I'm not the expert. Stefan is the expert later on in a session,
Yeah, 5.
a 3D session. But anyhow, we're going to go through a range of technologies. So for real time, it's definitely Sajid, the person to go to. What I've been playing around with, and I really enjoyed it, is multidimensional data sets. And I'm going to do the same because I'm really curious. How many of you here have used NetCDF or like multidimensional data? Oh, I see a few hands. Like 4 or 5. Okay, so this will probably be a bit new for everyone. So last year I was looking into like there's a lot of data out there that you can get as open data or so, and the one that I've been using was on carbon dioxide. So for the whole globe, there's a program called this is not Copernicus. And they have simulation. It's like a model of carbon dioxide at different levels, at different altitudes, and over a period of like 17 years. So I thought, okay, we've got like X, Y, Z data over time. This is perfect to visualize it in what we call a voxel layer, so for multidimensional data. And I'll go a bit later into the details of how I built this. But for now, let's have a look at the app. So we're looking here at the year 2020, and here you can see a histogram. So the levels of carbon dioxide range from 360 to 420, more or less. And what this means is that there are, for example, if I have 420, there are 420 molecules of CO2 in 1 million molecules of dry air. And you can see that the average is somewhere around here. We can look at it in a 3D scene. So for example, we can see that the lower values are a bit higher up, and then the higher values are obviously closer to the Earth. We can go back in time. We can go, for example, to 2015. I only added it for a few years. And we can see that the histogram already shifted a bit towards more like the green levels. But if we go all the way back to 2005, then we can see that here the CO2 levels were actually much lower, and there's quite a lot of green in the scene. One more thing I wanted to show you, I stole Sajid's trick with the divs. So these are actually divs in this scene, and they react really nicely when you hover over, and you can link them to the UI. And this is something that I really like, to have kind of like a smooth interaction between like UI and map and kind of blend it in, a bit similar to what Sajid does. So let's have a look at what these voxel layers are about. You've got your multidimensional data. You could have point data, for example, and in Pro there are tools to convert it to NetCDF, and then once you have it in NetCDF, you can load it in a voxel layer, and then you can publish it on the web. And later on tomorrow, I'll have a session on 3D visualization where I will show you another app where I use geology data. Like voxel layers are really useful for geology, where you can slice and you can create sections and show different surfaces. Right. So from atmosphere, we're going to go up in the space. We're going to look a bit at satellites. This is an app that I actually built. Well, I built it because my boss told me to. But I'm also super interested in, like, I feel like the satellite business is booming lately, and there's like so many of them, and they launch a lot of them all the time. So one thing I was interested in is why do we have satellites, right? Like, what are they useful for? And probably everybody knows localization, right? Like we have the GPS satellite system. Then we've got, in Europe, we have Galileo, it's called, and a bunch of others. But most of them are actually for communications. And this is also where the Starlink comes in, and their competitor OneWeb. So like providing, for example, internet for the whole world and so on. And then we've got Earth observation, which are like geared towards the Earth, and space observation are interesting because they have, I don't know if you can see it so well, but we've got like these orbits that go really high up. Right. And then another thing that I found interesting was to look at who owns them. And of course, the US is like one of the countries, well, I guess because of SpaceX as well, with most satellites. And then if you look at them by operator, you can see like Communications are the biggest two companies, so they're actually privately owned. And then I was like, okay, where's NASA? And NASA is not actually in the first 10. We've got the European Space Agency. So it's interesting to see how like companies kind of like took the business a bit to say, like took a head on this, and organizations are like more like if it's for exploration, and so they're not going to launch like gazillions of satellites. So what's the magic behind this app? Well, actually there is no magic. It's just plain old feature layers. What I had to do here was to make sure that I'm optimizing them. So for example, I generalized the hell out of these lines just to make sure like I don't have redundant vertices and so on. And another tricky part was the data. So if you guys know where to find good data, please let me know. I found this satellite database for all the metadata. So this was the hard part actually, all the metadata, like who owns it, when was it launched, and so on. I'm joining it with like two-line element data, it's called. So this is like the part that gives you where the satellite is flying, what's the orbit of it. And the joining part, again, it's a bit like they have each satellite has an ID that is like well-known and used everywhere, but many times like it doesn't really match. So that was a bit like, I would say that was the magic, there's the data processing. And one thing I wanted to show you, oh, I forgot to show you in the app, like you can also search for your favorite satellite. Disclaimer, it might not be there because of this whole like data part that was like a bit difficult to get actually complete data. You might not find it. But what we did here was to highlight a few. So we're highlighting the International Space Station, like everybody knows it. And here, one thing that I wanted to point out, and I think Sajid, you will also talk about it, is I'm using a 3D model, a GLTF, and it's actually a graphic with the GLTF symbology. So you can do that too. I highly recommend it if you have like little animations like this, like a model that you want to show. But then if you have a ton of them, you might want to go for the 3D object scene layer. I don't know if this tells you anything. Basically, it's like an optimized version is like it's like a scene layer where you can upload your own models, and then we'll make sure that we render them performantly. Right. This is a model I downloaded, I think, from Sketchfab. It was under Creative Commons, so there's plenty of sources out there where you can find such models. Just make sure you have the right license to use them. All right, so now we go from space back to Earth, back to daily lives. So I love to ride my bike. I was in an Airbnb here in Palm Springs, and I was talking to the lady, and I was like, oh, because she commutes to the convention center. It's like, by bike, it would be like 10 minutes. I was like, you should totally ride your bike. And I find it really cool to like look. So I found this data set for Cambridge to look like, where do people go by bike, from where to where? And if I've got this origin destination data, my dream for a while has been to make these arc lines and to animate them nicely, and to have like, the origin has one color and then it interpolates nicely to the destination. So I'm going to show you a demo where I did this. And this is where the render nodes come in. So having these arc lines, you could create them using geometry and graphics. Having a lot of arc lines like this, it might get a little slow. And animating them, it might get even a bit slower. So this is why I decided to use render nodes for this. So basically, I'm adding my own geometry to the scene. We're looking here at the 1st of January, 2024. So you can see all the people that probably went partying or something, and at 1 a.m., there's like quite a lot of activity. Like in the other days, you don't see this. They're like going from one place to the other. And the cool part about it, when you use render nodes, is that I'm just loading the geometry here. You could load also some attributes or so to display it, but here is just geometry. And I wanted to show, I made this slider. If we move it to I have no patience, this thing will start like going really fast. And if it's actually, if I move it to a day where there's a lot of activity, and here we can see on the 25th, this is a normal work day. Not much going on now, but at 6, it goes wild. So there's fireworks over here. And this is the cool part, I think, about render nodes. Like if you have something specific like this that maybe we don't support out of the box, like we don't have symbols for this, for example, lines and interpolating colors along the lines, then you could use this. And then also the fact that it's like so fast and responsive, I think this might also be an argument for using this. All right, so this was my Cambridge demo. Let's go now. Oh, this is what Sajid was saying about the render graph. So we have like different render passes. We, for example, display the atmosphere. I'm not putting them all here because if you want to see the complete graph and get scared, you should go to Stefan's session, the one I mentioned. It's in the afternoon. But for us, what's important to know is that if you have opaque geometry, you will add here, like when you create your render node, you will say, oh, it consumes opaque color, and then you will be able to kind of inject your geometry or whatever you want to draw in there. For transparent, the same. And composite color is like, let's say you want to make this cool effect in your scene, you want to have sepia or something, or we have a bunch of samples in the API to show you how to do this. Then you can take the whole scene, all the like the pixels in the scene, the colors, and then you can modify them. And for example, my next goal is to, you can also use the highlight, so my next goal is to have this super nice bloom highlight that makes you like feel like you're in a sci-fi movie, but I'm not there yet, but maybe by next Dev Summit I'll show you that to you guys. All right, so now that we've been on the Earth, let's go below the Earth. This is an app I made showing the deepest points in the 5 oceans. And the idea with this, it's more about like a nice little exploration app. I started building it because I was inspired by a video that my colleagues in the creative lab team did showing exactly this, but it was like a video, and I thought it would be really nice to have an interactive experience. So here's the globe, and here we have the 5 points. And the deepest one is Mariana Trench. So if we go here, now it loads another scene. And this is, again, something that you cannot really create like in the scene view or so, because you can see like you have this nice gradient here on the side, and the terrain also with like a gradient for like deeper parts are dark purple, and then higher parts are a bit more towards yellow. So this is all done with the mesh geometry. And this is just one example, but you might want to use it for something else. This is something in between the super low-level WebGL and loading a model where you didn't have to build it yourself. You can create things like this. So for example, if I want to make a pyramid here, I have my 5 vertices. And for each vertex, I'm going to define positions, which are like longitude, latitude, and altitude, and colors. And then all I need to do is create a mesh where I give this data, and then I tell it in the components part, I tell it how to put it together. So like to create such faces. So for example, I say, oh, connect vertex 0, 4, and 1 together and create a face. And you can also set materials with different properties. Like you can set the metalness and all these cool things to make it shine or so. And then you add it to a normal graphic. So this is one thing that you maybe might use. One thing we used it for, and this is a video that my colleague Arno did for showing how you can create terrain like this, because you saw like we had terrain in that app. So the first thing that you do is you create, like you have your extent, you generate some random points in there, then you triangulate it, and then you get the elevation from the actual elevation service, and you set it on those points, and then you convert it to a mesh the way I showed you. So like you basically have all those vertex attributes. Oh, I don't want you to see my recommendations. Oh, why can't I switch? Okay. What was I saying? Yeah, that you can create like a terrain like this, but you cannot go wild with the terrain. Again, this is client-side geometry, and it's going to be quite heavy if you want to do this for like a really big area. All right, and then It's focused on the video, that's why. The last one I want to show you is something that I was always into, watercolor. I like to paint. It's horrible, it's not nice, so I'm not going to show you my paintings, but I'm going to show you how you can use it in the JS API. And let me show you the live app first. By the way, this page, we have a link to it at the end, so you'll be able to check them out yourself and also look at the code with all these demos. So you know how sometimes in urban planning you have these really nice visualizations where you have like watercolor and it looks like it's hand-drawn and so on. And this was kind of a bit my goal with this. I took it actually from a real competition. So they were suggesting to add these 2 parks, and they had these nice user stories, how people would walk around with their dogs around here, and this could be a possible route to take, or like a student that does the morning jog in this area. And I think for me, just the nice part is to kind of visualize it in this way where it looks like it's kind of painted. And the way to do that is to follow John Nelson and then steal all his styles. So I took this watercolor style for Pro, and then if you publish it as a tile layer, it needs to be a tile layer. Like if you do vector tile or so, we won't render it, neither in 2D nor in 3D. So you need to have it like a web tile layer, create like PNGs out of it, and then load it in your web map or your web scene, and you've got a watercolor base map. I think that's it. I'll pass it on to Sajid now for more real-time big data.
Julie, do you want to switch to 4? So while I'm working with big data, Raluca's just watercoloring in her office all the time. But
I think it's a good combination, no? We need both in our lives.
I think I need watercoloring in my life. But how many of you work with big data over here? Okay. So the challenge with big data is always visualization, right? You can analyze the data on the back end, but then it becomes super difficult to visualize large sets of data. So this is an application that we built where we've got about 150 million parcels, and we've gone in, we've used our big data tools to go in and analyze the parcels based on proximity to highways, proximity to waterways, proximity to electricity, whether it's in a wetland or not. But then we are actually providing the full fidelity of the data in a client application. So you're looking at 144 million parcels. I could go in, I'm just going to zoom into the LA area over here, and you'll notice it reclusters the parcels. So I could go in and zoom in again. And I'm working with all of the data in the client application. So I could go in and say, set filters. Maybe I want to find all the parcels that are within a mile of a highway, and it'll reanalyze. And you'll notice it's actually pretty fast, right? In a couple seconds, it's going back, querying all of the data, coming back and rendering the entire US. It's also giving me statistics. So it's showing me what the average acreage of the parcels are, what the average assessed value is. So I could go in and say, show me everything that is within, let's say, half a mile of electricity. So maybe I'm trying to build a certain kind of facility, and I'm trying to identify which parcel is most suitable for that. But I'm not doing it like in one county or in one state. I'm doing it across the entire US, right? And just to see the performance, like I'm just going to zoom in. Or actually, I even have a list of all of the parcels over here. So I could go in and select one and zoom to it. And to show you that this is working with all 150 million parcels, I could go in and filter this and say, show me everything that's within quarter mile of a highway, and you'll see it updates that right away. So it really is providing all of the data that you can access, but you can do it in your browser now, right? So the way we are doing this is we're actually using the statistic definitions. So if typically you're running a query against a feature layer, what we've done is we've gone in and we've enriched the parcels with a geohash. So it's a combination of the latitude and longitude. And then we're using that attribute to summarize the queries. So you can just group by that geohash, and you can actually create these geohashes for multiple levels. So think of it as binning, but rather than saying everything falls in this bin, and then you're using the bin to summarize the data. We are just saying combine the latitude and longitude, create a new field. You can choose how many decimal places you want to. And then all we are doing is running a output statistics query on that same feature layer. And the group by field for that statistics is that hash field that you want to use. And like I said, you can have multiple hash levels depending on your zoom, so you can just summarize based on that. So the next application that I want to show is just an operational digital twin. So this is more of something that organizations would use at their operation centers. This is for wind energy. It's off the coast of UK. And we are monitoring, I think it's about 1,200 wind turbines off the coast of UK. There's some that are onshore as well. But the cards that you see on the bottom are actually showing you the wind turbines that are either not producing any energy, so the ones that are in red are completely still, they're not producing any energy. The ones that are in orange are producing below their optimal level. So this isn't, unlike what you saw with the public transportation twins, that's more of a public-facing app where, anyone can go in and see when the next train is going to arrive, or, where a certain train or bus is. This one is more internal, where people, there are analysts or engineers that are monitoring it. And I can go in and see, I can just zoom to a particular wind turbine. So this one is an onshore wind turbine. You'll notice it's part of 6 turbines in a farm. There's only one that's not producing anything. This one over here is an offshore wind turbine that's not producing any energy. But it is like a pretty comprehensive twin, because I can go in and look at what's happening inside the wind turbine, right? So this, like Raluca said earlier, is a GLTF model of the wind turbine. It is actually just a scene view. So I can interact with it, I can zoom in. It's showing me which of the sensors are triggering alarms. There's a pitch drive hydraulic sensor, and then it's also showing me who the nearest field worker is to that wind turbine. So if I do need to dispatch somebody, I know exactly who's close by. But I can actually go in and interact with the sensor, and it's now taking me to a graph view that connects to a graph database. So I could go in and say, show me which turbine this alarm is on, show me which model of wind turbine this is, show me who the manufacturer of this wind turbine is, and I can say, show me all the suppliers that supply parts for this particular wind turbine. Now, because it was the pitch drive hydraulic sensor, I'm going to pick the pitch drive supplier and then say, show me all the other manufacturers that use that particular supplier. And I'm going to say, show me all the other models of wind turbines that use that particular part. And then I'm going to say, show me all the turbines that we manage, right? So this is essentially your typical car recall scenario. So you have a faulty airbag, you know what models of cars you've used it in, which years of models those cars use that particular faulty airbag, and then you go and identify who you need to notify about the recall notice, right? But while I was navigating the graph, it's actually filtering the features on the map itself. So I can go ahead and close this. And these are all the wind turbines that are using that particular pitch drive hydraulics part, right? And you'll notice that there's one that's not producing any energy, there's one that's below its optimal level. All these others are green, so they're producing what they should be producing, so I could go in and zoom to them. So it's probably not a faulty part that's the cause of the problem, it's probably something else. But this kind of helps you establish those correlations between what's spatial and what's not spatial. So you're kind of combining the two things in one application, right? And as these twins mature, you'll see more and more of these multiple data sources, multiple types of analysis that happen within the same application. So what's really happening behind the scenes in this application? So there's one simple thing. The water is a simple water renderer that you can use. You just define, which features you want to apply it to, whether it's a large water body or a small water body. You can choose the color that you want to symbolize it. And then, you just point it to your feature layer, and it does everything for you. So that's like the simple trick. a little more complicated trick is using these GLTF symbols. So GLB is basically the binary form of a GLTF. Like Raluca said, you can get these models. So if you have, let's say you have factory equipment that is standard, you can actually just you can either purchase a model or you can download one for free from, there are multiple websites that you can get them from. And then you can use that as a symbol just like you use like a PNG or any other marker symbol, and you can actually create a whole map. You can even like create layers and use these GLTFs. I think the 3D session shows you how to do that. I think they showed that during the plenary as well. So the last part of this application is we actually do have objects or classes within the JavaScript SDK to connect to knowledge graph services. So just like you connect to the REST endpoint of a feature service, you can actually import these classes into your application, and then you can send an OpenCipher query. If you're familiar with OpenCipher queries, it's pretty easy to do it. If you're not, it's a little more complicated because it's not like SQL queries. You have to kind of learn that part. But you can also create a knowledge graph layer in your map. So it'll show you all of the entities that are spatial. Obviously, if there's entities that are non-spatial, you can't add it to the map. But you can get to them through the query part of the knowledge graph. So I'm going to show you two more applications. And I think I'm like a two-trick pony. I use the same two tricks in all of my applications. So you'll notice that these applications use some of the things that I've already shown. But I want to show you like what you can build with the SDK. So this is a situational awareness twin. It is a refinery in Miami. This again is real-time data. So we are monitoring incidents that are happening around the refinery. So typically if you're managing any infrastructure like a water treatment plant or like airports or stations or refineries, there have been these attempts of hackers or people just going and throwing things or shooting at these facilities. So it's become more important for them to kind of monitor what's happening, not just on the facility, but outside the facility as well. So over here we have real-time incidents. This is coming from a partner of ours called DataMiner. And right now there's no incidents that are affecting anybody, but I can select one and go to that incident, and it'll show me essentially where that incident is and if it is affecting either the refinery itself or if it is affecting any of the off-site field workers. So because they have people that go out to the port or go out to the airport, they are keeping track of who's within the facility as well as who's outside the facility. So in this case, I have some on-site sensors as well. These are methane sensors. So over here, I've just set up a rule that says if the methane level is more than 1900 particles per billion, trigger an alarm. But then I can go in and see which sensor is triggering that alarm. And then it'll also show me who the workers on the facility are that are closest to that sensor, right? So the worker locations are actually managed by this RFID badge, so they just know which building they are in. They don't really track the workers, but they know who's close to that sensor or who needs to be notified or how many workers are actually within close proximity to that sensor. So you can do the same thing. You can monitor off-site personnel. So I could go in and you can see there are two personnel that are impacted by incidents. I could select this one, and it'll show you where she is as she moves in the field. It'll keep updating her location, and then it'll also show you where the incident is that is likely to impact her, right? So it's 4.1 miles away, there's a crash, and this actually is real-time data right now happening in Miami. And then because it's critical infrastructure, they also need to monitor ships and aircraft that are within a certain distance from the refinery. So this is using the AIS stream to identify vessels that are in close proximity. I could just go in, select a vessel, and it'll show me where that is. So the minute there's any kind of vessel that's within, I think it's 2 miles of the refinery, it triggers that alarm status, and you can monitor which ships are coming close or moving away from the facility. And we can do the same thing with aircraft as well. So I could go in and look at looks like a JetBlue is landing at Miami Airport, but it's within 10 miles of the refinery, so it kind of notifies us that, hey, there is an aircraft within a close proximity. So you probably noticed that it's using the same tricks. There's the RenderNode trick. There's the div that's on top of the map, that we can manipulate in 3D. The last application that I want to show you is an AI mapping application. How many of you saw the AI demo in the map viewer yesterday? Okay. So it was pretty inspiring, right? So yeah, I got inspired. I went back to my hotel room last night and I asked ChatGPT to build this app. And we've actually been working on this app for about 3 weeks now, and it's designed for my managers, because if you're a developer, you know how annoying it can be when Wednesday morning you're sitting and watching TV and your managers call you and say, hey, can you show that app to this person or so-and-so because we are in an important meeting. So I figured Gen AI is probably the best tool to make my app simple enough so that my managers can do their own demos. So this is like a one-button app, and I don't know if Raluca told you, but she's from Zurich, and Julie's from San Diego. So we're going to give the app a simple test. Is San Diego or Zurich further away from Palm Springs?
Zurich is further away from Palm Springs than San Diego. Zurich is 9,456 kilometers away from Palm Springs, while San Diego is only 137 kilometers away.
So now, obviously, you're thinking, do you really need AI to answer that question? And the only reason you're thinking that way is because you don't know my managers. But I think this is how AI kind of disarms us, right? It gets the first question right, and now implicitly, we are skeptical at first, and we'll ask it a question that we know the answer to, and it gets it right, and now we're going to trust all the other answers that it's going to give us. But we thought that, as a developer, it's really hard to build digital twins because you're working with graph databases and you're working with real-time data and big data, and you kind of have to learn the syntax of how to query all these different data sources. So we thought like a supply chain data set would be a good use case for using Gen AI to do generating all of the queries and the syntax that you need to pass. So we wired this up to some supply chain data. Find a factory near Berlin and a store near Miami. So this is actually sending the prompt to Gen AI, and it generates a query. It says, I have these certain data sets. I have some assets that are factories. I have stores. I have like distribution centers. So it goes and finds that. So now I'm going to say, show the quickest route from the factory to the store. So now it's actually going to try and generate a network solve query. So it's showing me that I can actually, and this is actually, the data is modeled around a luxury car manufacturer in Germany. So they do have specific nodes that they go through. So it's not like they just use UPS or FedEx or DHL to send their stuff. So while you're driving that gas-guzzling SUV from Germany, you want to pretend that you're environmentally conscious. So let's say, show me the route with the smallest carbon footprint. So you'll notice that it switched from sending it by air to sea. So it's generating the parameters that you're going to send to the REST API based on the prompt. But I can go in and say, show me all the suppliers that supply parts to this factory. So now it's actually generating an open cipher query. So For me, I could either buy the book and sit and learn OpenCipher query or use GenAI to generate that query for the application. So it understands the intent of what I'm asking it to do, and it's actually generating that query so I can send it to the REST endpoint and get the data set. So remember, in the wind turbine one, I had to go and click and nodes and go through it. I can just say, show me the vendors that supply materials to these suppliers. So it's essentially doing all of that. I don't have to train somebody on, you have to find the manufacturer and then the supplier and then the part and go that way. But it's actually going in and doing all of that for you because Gen AI is understanding what you're trying to find, right? And because it's essentially a large language model, I can speak to it in any language. So I can say, montrez-moi les risques. So I just asked it to show the risk in the supply chain, and now it's going to a RAG or...
Il y a 3 actifs qui posent problème. Le 228 par supplié et le Noada par supplié sont menacés en raison d'éventuelles grèves et retards. Le vendeur de matériaux de Waterbury est menacé en raison d'une possible instabilité politique.
So I don't know what she said because I don't speak French, but I've tested this out in English, and essentially what it is doing is it's going to a different AI model. So it's not the large language model. We have a separate model that's trained on unstructured documents that have labor issues around the world or political issues around the world. So it's using the LLM to identify the intent, then it goes to this RAG or retrieval augmented generation model to identify which locations could have possible issues or delays related to labor or political issues. And then it sends that back to the LLM to go in and interpret and give you the answer. So that was the last application that I had to show. If you like the session, only if you like the session, please take 2 minutes to fill out the survey. If you didn't like the session, I think they're serving beer in the lunch line, so you should rush there. And with that, I'll open it up for questions. I think the QR code, do you want to talk about the QR code, Luca?
Oh, that's just the link that you guys, when I was showing my apps, it's a link to the apps.
No, for my apps, you can just go to ChatGPT. I mean, you can't be that lazy. All right, so here's our email addresses, Twitter handles, but we are open to questions. Anybody?
I'm going to start with a question from the audience. You can come up here to a microphone.
Hello.
Hey, I recognize you.
Hey, how's it going? Sajid, we appreciate all you do. A question about the site locator app. Desperately seeking some form of binning within the 3D view, within a scene view for the JavaScript API. And it looks, although it looks like that app, it wasn't clear if it was the map view or the scene view. Could you use that strategy for binning within the scene view?
Yes, absolutely.
Great.
So I haven't shown a couple applications, but we've done a few applications where you can actually, it's essentially the same data, right? It's a feature layer, so you can use it in the scene view as well.
Great, thank you.
And that's definitely a custom implementation for binning. Yeah, you know that. Any other questions in the audience before we go to the chat? No? Okay. So there's a question online for Sajid. Let's see. So this was for the windmill app. What are you using to visualize the windmill from a web app? Visualize it from a web app in the knowledge, symbology, and transparency. He understands you were using the ArcGIS knowledge graph stuff, but he wants to know how you did the visualization part.
Okay. So I think the question is, how am I rendering the graph in the application? And it's actually, it's a map. So it is actually a 2D map where we are querying the features from the knowledge graph, and we're just creating graphics on the map. But you can use, if you're comfortable with using some other library to render graphs, you can use that. They work great. I've tested out different libraries, and you can use that as well.
Okay, next question from Rahul. How do you create a hash field?
So the simplest way to create a hash is to just concatenate the latitude and longitude. So you can do lat_long, and you can do it at multiple levels. So you can say, give it to me at 4 decimal places, or give it to me at 3 or 2. And then you can use those different levels to kind of group your query statistics so that you get it at the appropriate level. The other way to do it is to just give it a bin ID. So you can use Uber's H3 bins if you're comfortable with that, and then you kind of like tag every feature with the bin ID, and you can do it at multiple levels, and then you can aggregate by that bin ID as well.
Thank you, Sajid. So let's see here. Esri Argentina developers would like to know, is there other animated 3D visualization possible? I think they're talking about like animating along a line. It said it'd be cool to show shortest path between bike stations or something. And I think that's what you essentially were doing in the GeoAI app. You were like animating between points.
Yeah, so there's really no limit to what you can do with animations. I think it depends on how much time you want to spend. So when I did my first WebGL application, it took me a while to just understand GLSL, so it's not as straightforward as just picking up JavaScript or picking up Python or some other language. So it's a little trickier, but once you figure that out, there's really no limit to what you can do in terms of animation.
There's a question about the slide deck. Will it be available after the presentation? All you have to do is search for Esri recent proceedings, and after the conference we post the PowerPoint. Is there any other questions in the audience? Nope. Okay. Oh, I think we got, looks like there's more clarification wanted for the knowledge graph part. He says, but how are you rendering the knowledge on a map? Is it through a layer?
So it's actually, think of it as 2 maps. One is 3D, a scene view. The other one is a 2D map. And it's 2 different div tags. The 2D one is on top of the 3D one. And then within the 2D map, you can render graphics. So you can just create, it's like, there's no base map in the 2D map. You're just rendering the graphics from the graph.
Well, and we do have a knowledge graph layer as well. Yeah.
What is the position on the map, Sajid, then?
So you can just use like a force distribution algorithm to place them anywhere, right?
Okay.
So you just give it coordinates.
It's kind of random, right? It doesn't mean anything. Yeah. Okay.
If there's no other questions, I guess I could ask Raluca a question. You were showing how you love the smooth animation using the HTML little points for how you're doing that. And was it the carbon dioxide one?
Right.
So why did you use that instead of like actual symbols? And how does that help the animation?
Because then you can use CSS transforms, like the stuff that Sajid did, and then on hover you can go wild with them. Whereas it's a bit trickier to transform it and have these nice animations.
Okay, that makes sense.
Yeah.
Come on, guys, I'm really trying here. I need one question. Okay.
With the information they had at the bottom of the screen, with the windmills, how did you build that? Was that just divs that you?
That's just divs, yeah.
Cool.
Yeah. So I use React for most of my applications, and then you just create like a React component, and each card is a component. So depending on how many, features you need to display, it just automatically creates those. But it's essentially a div.
That's cool. Thanks.
I have a question. So your trick of rendering content on top of the map, I was wondering, what happens when the user changes the view of the map itself? Does that also recompute the positions of the divs on the map? Or?
So you'd have to, so essentially you're setting up a watch on the extent change of the map. And then when the extent changes, that you run that toScreen method again, and you update the position of your div.
Okay, that can be kind of like performant. It can affect performance a little bit if you have a lot of elements, right?
Yes. So yeah, if you're trying to create a div for every feature and you have like thousands of features, it could lead to a performance issue. So you want to use it selectively, like not, for every div, like for every feature rather.
So as the user changes the view, how do you handle rendering as the user is changing the view? Like there should be like because it could be like a lot of different view changes and a lot of different recomputes.
So I'm not sure if I understand it correctly, but I think typically what I do is if the view is animating or moving, I hide the div. If you have many divs, right? Because then you're kind of like creating this effect that's undesirable. If it's one, you can animate it in real time, so you can move it. You can set a transition on the div so that it goes smoothly.
Okay. Right.
So it really depends on the use case. Typically, if it's one or two divs, you want to use it when you're highlighting features, not for every feature on the map.
Okay. All right. Thanks. Appreciate it.
Okay. Are there sample code snippets online demonstrating these tricks, specifically the smooth transit vehicles moving?
I think there's one with 2D WebGL layers in our sample code.
You mean the custom layer view with DeckGL?
Yeah.
Yeah, there is a sample showing how you can integrate DeckGL as like a custom layer view that has like transit lines, but yeah, that's definitely 2D and you can't just easily use that same sample in 3D. It's different implementation. I don't know if you...
We can try and create a sample or something that's... We'll put Raluca on it.
The custom render nodes, that's going to be an area where I think the team's going to grow more samples and more out-of-box capabilities. So that's just the beginning of that capability. So I think that's where we would be able to post a sample in the future. But I don't know of any 3D
maybe
samples.
We could put the one with the windmills that are spinning, just to give people an idea.
Oh yeah,
of the
okay, yeah. There's so that's a little that's let's
maybe
see. I know which one.
It also in the chat.
Let me see which one is that one?
Do you have a question?
Yeah, I had a quick question. So beautiful apps, 10 out of 10. I had a question about the GOA.
I didn't hear that. Can you repeat it from the managers, please?
Beautiful apps, 10 out of 10.
Thank you.
For the GOAI app, what library did you use for the voice recognition for that functionality?
So I'm using Azure Speech to Text, and it's part of their AI services. There's Azure Speech to Text, there's Azure Cognitive to detect the language, and then we're using Azure OpenAI for the actual LLM.
Gotcha, thank you.
Sure.
So the one on the screen is the one that Raluca was talking about with the windmills. Did you want to say something about this one?
I mean, it really gives a good example of how to animate like the wind blade, so like animating 3D models. If you go and look at the code, then you'll see how complex it is. And then from there on, like I feel like once you understand the principle, then you can like go and animate anything.
Do these techniques only work for custom apps, or do they work in Experience Builder? It definitely works in Experience Builder. You would just need to write, a custom widget to implement it. It's using the JavaScript SDK.
Yep.
Are you typically using WebGL or 3JS? Any disadvantages using 3JS versus WebGL?
So I'm using WebGL. But
Did you ever use 3JS?
I have used 3JS in the past. So the difference is in 3JS, it gives you some methods to create 3D objects. So it's easier if you're not familiar with WebGL. But more recently, once they came out with external renderers and the render nodes, I've switched primarily to WebGL. But you can use 3JS. There's no issue with it.
I'm posting the, oopsie, I'm still sharing my screen. I'm going to post the chat, the URL to Raluca's source code in the chat. So for anybody that was trying to get that. There's one more question that we have time for. Let's see. Oh, did you build your apps with responsive design? Can you use them on a mobile phone?
Some of them you can. So I think I'm trying to think which one won't be responsive. I think most of them should be responsive.
What's your strategy, Sajid? Do you remove things if it gets too complex?
Yep. So
Sometimes it's just too much to show on a mobile screen.
yeah, so you'll notice in most of my designs, like the information panel's on the bottom because you can scroll and then it kind of doesn't interfere with the map when you're on a smaller device. I think the wind turbine one may be a little hard to use on a phone, but that's more an internal app than a public-facing app. So typically it's designed to run on a huge screen at their operations center.
Okay, thank you everybody for joining us, and session's over.
Thank you.